Today we'll be building a sediment column. A sediment column is often made up of mud, water, and various other nutrients. Sediment columns can be used to form small ecosystems that promote enriching sediment microbial communities. These microbial communities can be further used in microbial fuel cells. MFCs are a way for the microbial communities to generate energy and a way we can measure, in volts. In our experiment, we created 3 sediment columns to observe over the course of 6 weeks. The first column contains sediment from the local retention pond in Harrisonburg, 5 grams of egg, fish food, manganese sulfate, soy broth, and dry milk. The second column contains sediment from the local retention pond in Harrisonburg, 5 grams of ferric sulfate, and fish food. The final column contains sediment, 5 grams of calcium and sugar. The purpose of combining multiple combinations of mud, water, and various materials is to determine how those nutrients affected the gradient of the column. For the first column, the cap was placed on top and closed to ensure no excess oxygen could enter the system. This allowed for a control bottle that only contained what was placed inside it. The other bottles were left open to allow for oxygen to make it into the column. Step 1. Source the sediment from the retention pond. Fill the column first with sediment and use a vortex mixer to vibrate the column. This allows for all air bubbles within the sediment to rise and escape. Step 2. Add nutrients. Mix of nutrients depending on the column. Step 3. Create columns with different types of nutrients. Step 4. Label all 3 columns with identifiers specific to our group. Step 5. Place columns in the oxygenated water tank. Bottle number 1 is capped to keep any oxygen in while the 2 other bottles are left open. Step 6. Observe the bottles every week. These are the sediment columns just after adding all the ingredients. During the first week of observations, we notice most of the sediment has completely settled at the bottom of each column and only water remains at the top. In the second week of observations, we see distinct layers beginning to form and the iron from bottle 2 is being oxidized. In week 3, bottles 1 and 3 have thin, dark layers of sediment at the top of the sediment. In the last week of observations, bottle 3 has the darkest layer at the top, while bottles 1 and 2 have a slight color gradient with darker sediment at the top and lighter sediment at the bottom. That is how you build a sediment column. Stay tuned for when we build a microbial fuel cell.